cannot feed multi-wire circuits from a tandem 20.20 circuit breaker. A tandem circuit breaker is a single device containing two independent circuit breakers, each with its own terminals and handles. Each breaker in a tandem pair can control a separate circuit, but they share a common trip mechanism. If one circuit trips, it will also trip the other circuit, even if the other circuit is not overloaded. Multiwire branch circuits, often abbreviated as MWBCs, are a type of electrical circuit that use two or more current-carrying conductors, otherwise known as hot wires, and a single neutral conductor. The hot wires are connected to opposite sides of a double-pole circuit breaker, while the neutral conductor is connected to the neutral bus bar. This configuration allows for two separate circuits to be run on the same cable, which can save space and reduce installation costs. However, MWBCs cannot be fed from a tandem circuit breaker. The common trip mechanism in a tandem circuit breaker would prevent one circuit from being powered if the other circuit tripped, even if the first circuit was not overloaded. This could lead to a dangerous situation where a portion of a circuit is left without power, potentially causing a fire or other hazard. For these reasons, it is not permitted to feed MWBCs from a tandem circuit breaker. Instead, each circuit in a MWBC must be protected by its own dedicated circuit breaker. It is important to understand the nuances of circuit breakers and multi-wire branch circuits to ensure electrical safety. Firstly, consider the function of a standard circuit breaker. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset, either manually or automatically, to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect individual household appliances up to large switchgear designed to protect high-voltage circuits feeding an entire city. The generic function of a circuit breaker is to protect a circuit from overcurrent conditions, which can arise from a short circuit, an overload, or ground fault. Short circuits occur when there is a low resistance connection between 2 points in an electrical circuit that normally operate at different voltages. This can cause a very high current to flow, which can quickly overheat wires and cause a fire. Overloads occur when a circuit is trying to carry more current than it is designed for. This can happen if too many appliances are plugged into a circuit at the same time. Ground faults occur when a current-carrying conductor comes into contact with a grounded surface. This can also cause a high current to flow, which can be dangerous. Circuit breakers detect these overcurrent conditions and interrupt the flow of current to protect the circuit. There are different types of circuit breakers. Miniature circuit breakers, or MCB, are thermomagnetic devices commonly used in residential and light commercial applications. They are designed to protect against overloads and short circuits. Molded case circuit breakers, or MCCBs, are used for higher current and voltage applications in commercial and industrial settings. They offer a wider range of interrupting capacities and can include additional features like adjustable trip settings. Air circuit breakers, or ACB, are typically used in high-voltage applications. They use compressed air to extinguish the arc that forms when the breaker trips. Secondly, understanding multi-wire branch circuits is crucial. A multi-wire branch circuit is a type of electrical circuit that shares a common neutral conductor between two or more ungrounded conductors or hot wires. These hot wires originate from different phases of a multi-phase power supply, such as a 120/240 volt single-phase system or a 208 volt or 480 volt three-phase system. The key advantage of a MWBC is its efficiency. By sharing a single neutral conductor, the number of wires required for multiple circuits is reduced, which can save on materials and installation costs. In a typical 120/240 volt MWBC, two 120 volt circuits share a neutral conductor. Each hot wire is connected to a different leg of the 240 volt supply, ensuring that the voltage between the two hot wires is 240 volts, while the voltage between each hot wire and the neutral is 120 volts. This arrangement allows for two separate 120-volt circuits to operate simultaneously, with a neutral conductor carrying only the unbalanced current between the two circuits. The current on the neutral wire will be the difference between the current on the two hot wires. For example, if one hot wire is carrying 10 amps and the other is carrying 8 amps, the neutral wire will carry only 2 amps. However, if the two hot wires are on the same phase, the neutral wire would carry the sum of the two currents, potentially overloading the neutral conductor. The National Electrical Code, often abbreviated as NEC, has specific requirements for MWBCs to ensure safety. Firstly, all hot wires in a MWBC must originate from the same panel. Secondly, the circuit breaker protecting a MWBC must simultaneously disconnect all hot wires. This is typically achieved using a 2-pole or 3-pole circuit breaker, depending on the number of hot wires in the circuit. Thirdly, the neutral conductor in an MWBC must be rated to handle the maximum unbalanced current that could flow on it. Several benefits can be obtained from using MWBCs. They reduce wiring costs. By sharing a neutral conductor, the total amount of wire needed for multiple circuits is reduced. They increase circuit capacity. MWBCs allow for 2 or more circuits to be run from a single cable, which can increase the number of available circuits in the given area. They improve voltage stability. By balancing the load across multiple phases, MWBCs can help to improve voltage stability in a building. Thirdly, the incompatibility of tandem breakers with multi-wire branch circuits must be acknowledged. A tandem circuit breaker, also known as a duplex or twin circuit breaker, is a type of circuit breaker designed to allow 2 circuits to be installed in a single circuit breaker slot in an electrical panel. This is achieved by combining 2 individual circuit breakers into a single unit that occupies the same space as a standard single-pole breaker. Tandem breakers are commonly used in situations where an electrical panel has limited space and additional circuits are needed. Each breaker in a tandem breaker has its own separate trip mechanism and can handle its own independent load. However, both breakers are housed within a single unit and share a common connection to the panel busbar. While tandem breakers can be a convenient solution for adding circuits to a crowded panel, they are not suitable for use with multi-wire branch circuits. The reason for this incompatibility lies in the shared trip mechanism of tandem breakers. In a MWBC, the hot wires must be connected to different phases of the power supply to ensure that the neutral conductor only carries the unbalanced current. If a tandem breaker is used to protect an MWBC and one of the breakers trips due to an overload or short circuit, the other breaker will also trip, even if the circuit it is protecting is not experiencing a fault. This is because the 2 breakers in a tandem unit share a common trip mechanism. The simultaneous tripping of both breakers in MWBC can create a dangerous situation. If one of the circuits is supplying power to critical equipment, such as life support systems or emergency lighting, the unexpected loss of power could have serious consequences. Additionally, the sudden interruption of current flow in the MWBC can cause voltage surges that can damage sensitive electronic equipment. For these reasons, the NEC prohibits the use of tandem breakers for multi-wire branch circuits. Instead, each circuit in the MWBC must be protected by its own dedicated circuit breaker, typically a 2-pole or 3-pole breaker that simultaneously disconnects all hot wires in the circuit. The use of tandem breakers with MWBCs can also lead to other problems such as unbalanced loads and overloaded neutral conductors. If the loads on the 2 circuits in the MWBC are not properly balanced, the neutral conductor can become overloaded, which can create a fire hazard. Additionally, the use of tandem breakers can make it difficult to identify and troubleshoot problems in an MWBC, as the simultaneous stripping of both breakers can mask the underlying cause of the fault. To ensure the safety and proper functioning of electrical systems, it is essential to follow the NEC guidelines and avoid the use of tandem breakers for multi-wire branch circuits. Instead, use dedicated circuit breakers that are specifically designed for use with MWBCs. This will help to prevent dangerous situations and ensure that electrical systems operate reliably and safely. The NEC provides specific guidelines for the installation and protection of MWBCs. NEC Section 210.4 covers multi-wire branch circuits. It specifies the requirements for the overcurrent protection of MWBCs, as well as the methods for identifying and disconnecting the hot wires in MWBC. NEC Section 210.4b states that multi-wire branch circuits shall be permitted as branch circuits. All conductors shall originate from the same panel board. NEC Section 210.4c requires that where more than one nominal voltage system exists in a building, each ungrounded conductor of a multi-wire branch circuit shall be identified by phase and system. This can be done by color coding, marking tape, tagging, or other approved means. NEC Section 210.4d states that in dwelling units, all multi-wire branch circuits shall be provided with a means to disconnect simultaneously all ungrounded conductors at the point where the branch circuit originates. This can be achieved by using a 2-pole or 3-pole circuit breaker that simultaneously disconnects all hot wires in the circuit. It is important to follow these NEC guidelines when installing and maintaining MWBCs to ensure electrical safety. Failure to comply with these requirements can create dangerous situations and increase the risk of electrical fires and other hazards. In summary, tandem breakers are not suitable for use with multi-wire branch circuits. The shared trip mechanism of tandem breakers can create dangerous situations and prevent the proper functioning of MWBCs. The NEC prohibits the use of tandem breakers for MWBCs and requires that each circuit in MWBC be protected by its own dedicated circuit breaker. By following these guidelines, you can ensure the safety and reliability of electrical systems. It's always best to consult with a qualified electrician when working with electrical systems.